We are in a kind of wiped out version of our program here. This is basically the same program we were using in the last section, but I've gone and deleted everything out of it. So first thing I want to do is click on Add New Block, and I'm going to go ahead and take a function this time. So we are not going to be retaining data from scan to scan. And I've already got it selected here. The language is FBD, which is exactly what we want because we're playing around in function blocks. And to give this thing a name, I'm just going to go ahead and call this the black adder because we're going to be using this to create an adding machine. All right. So here we go. We've got our function block program all set up here. And I'm going to come over here to the right, and here we go. You know, you can see all these instructions, they look very familiar, right? Well, I'm going to pull the add in, and watch what happens when I do. You see, we don't have a ladder anymore. Now we've just got this block kind of floating here in space. And if I wanted to bring in other blocks, you know, you see I can put them under there in the network. So this one is going to act first, and then this one's going to act second. And I can even use this other network. So once this network is done running everything in here, it's going to come down and run this next network. Okay, so that makes sense. That's kind of intuitive. That's what we expect by now. And I'm going to go ahead and get rid of this junk out of our program. So we've just got our adding machine. And to start with, you know, let's do something really simple. So I'm going to give us a val1, which is already defined, and we've got a val2 here, and we're going to use these to set a val3, which we'll also define as being global, and an integer. Perfect. Okay. And we need to know when this add block is going to be energized. Now in ladder logic, that en was usually right there on the rung, which means it was always energized. Right now we don't have, you know, anything, we don't have rungs. Well, we can put, you know, something like a normally open contact on there, or we can put some more logic like an OR on there or something like that. And or, you know, an assignment. We can do all kinds of things and determine when this thing should be energized or when it should not. Or if I want it to just be energized all the time, I can just type true in there. So I put a constant Boolean value of true on there, which means anytime this function gets called, you know, this isn't dependent upon anything to run. It's just going to instantly execute and go. And we don't really need anything to tell us when this block is energized and, you know, creating an output. So we will leave it just like that. And let's put this into our main and see how it works. So I'm going to open up our main, and now we've, you know, got our familiar ladder environment back. And I'm just going to drag my black adder over here and drop it right there on the line. And when I do, you see I've got a very simple little box. It's always energized by the rung. It's always, you know, ready to go. And this thing should be ready to run. So let's go ahead and get it loaded up onto our simulator. So let's see. It's starting up. And very slowly deciding to compile. I don't know why my computer's running a little slow today. I should probably restart that thing, but I've been lazy about doing it. If this thing starts lagging on me or something, yeah, I guess I'm going to have to cave in. And we want it to start the module, finish it up. Okay, we are online with this thing. And I want to minimize our simulator, and let's look at our, we could look at this and see what's going on. So let's go ahead and enable monitoring. And there we go. So this is running all the time, and it's adding 0 and 0 together, and it's setting value 3 at 0. That's fantastic. Let's go ahead and modify values and put a 5 in there. And you know, look what just happened. When I set that 5, my value 2 also jumped up to like 1280. And the reason is apparently I've got value 1 and value 2. The memory that they occupy seems to be like on top of each other. They're interfering with each other. When I set one, I affect the other. So let's do this. I'm going to go ahead and I'm going to change this, and I'm going to make it something like a val 4, and just give us something fresh to work with that's not overlapping like that, because that's really kind of annoying. I think I manually defined that memory address, and I think I did it wrong, so not a big deal, but it's not a mistake I want to live with either. Alright, so load. Okay, now I should have something that I can work with independently, so let's set that to 20, and there we go. So we've got 20 plus 5 equals 25. If I bump that 5 up to 50, and now 50 plus 20 equals 70. Alright, so we can see that add block is working. Now, let's step this thing up a notch. We don't probably want it to add, 50 and 20 all the time. Maybe we would like this thing to add something a little bit, we want it to add basically whatever we want it to add. We want to be able to determine our own numbers on our own dime and send those in. We can do that. So I'm going to replace val 1 and val 4 with some different variables, some different tags here. So I'm going to call these like INV for input value, and we'll say INV1 and INV2. Okay? And I'm going to define these. Now, in our section of memory here, you already know we've got, global inputs and global outputs. Those are, input devices coming into our PLC. And global outputs, those are output devices that we're controlling, like pumps and motors and drives and things like that. Then we've got our local temp memory. And that memory just vanishes from one scan to another. But I want to show you these two right now, this local in and local out. I'm just going to use local in for right now, but once I do, you'll understand automatically what local out does. And don't worry, we'll be using local out by the end of the course as well. So I'm going to define this right now as an integer, and it's going to be a local input. And the same thing for this. It's going to be a local input and an integer. So I've defined both of those. Now, when I come back over here to main, something interesting is going to happen. First of all, let me stop our PLC, because what I'm doing is kind of a big deal in the program, and go offline. And I'm going to delete this instance of black adder, and I'm going to just bring it right back in here and drop it. And when I do, it updated, and look at that. Now it's looking for input value 1 and input value 2. So now I can decide what values I want to put in there. When I do, I'm going to send those two values into this function. It's going to add them, and it's going to set that to value 3. So now from my program, I've got total control of that, and watch what I can do. So if I want to go ahead and throw another branch on here, and I don't know, let's say we are going to pull in a move, and we're going to set some value. So maybe we're still working with our val 1 and val 4. And here we can set val 1 to 5. Or we could go somewhere else and we could set that to a different value. So I'll just create a switch right here. Right click, define that. We'll go ahead and make that global so that we have control over it. And let's put one more rung below there. And we're also going to look at switch, but this time with a normally closed contact. I'm going to copy that move and bring that down here. And instead of 5, why not make it 55? Okay. And here we will send in our val 4. And down here we'll send in our val 1. Okay, so now we've got something that's going to allow us to flip this switch back and forth and send in a different value into our function. And it would be nice to be able to monitor and see what our value is without having to go to a watch table or something like that. So I'm just going to cheat. And I'm going to pull in an absolute value. I'm going to have to put that on a rung, I suppose. So rung, absolute value, and we were storing those to val 3. There we go. So as long as we have a positive number on val 3, this is not going to change anything. There, I got the wrong thing there. So this input should be 55. There, okay. So no more bad clicks. I've got everything where I want it. Let's go ahead and run this. Checking, loading, load. Start the modules after it loads. Finish, go online, monitor, and hide our properties down here. Okay, so our black adder is running all the time. Right now it's adding 0 and 55, and what we're getting out of it down here is a 55. Alright, that's perfect. And that val 4, somehow I put that in there as a local variable. I don't want that as a local variable, so I need to just go ahead and delete that out of there. Delete that pound sign. Okay, that's what we want. We want the actual global variable value 4. So let's put that into the PLC. Okay, no more screwing around. Let's go back and great, we're running. Let's get rid of our properties again. Okay, now can we set our val 4? Yes, so let's make that something a little more interesting than 0, like maybe a nice 20. And so you can see we're adding 50 and 50, or 20 and 55, and we're getting that 75 out. And watch what happens when I toggle my switch. So let's modify that to 1. Now we're getting a 25 out because now our value 1 is a 5. So we're adding 5 and 20. And we haven't changed our black adder. Our black adder is saying, hey, whatever 2 numbers you send me, I'm going to add them together and I'm going to put that into value 3. But in the main, we can decide what we want to send into black adder. So working with function blocks and using local in and local out, we can create these nice little machines here that, boom, will do whatever we want, and we can control the inputs that go in, and we can even determine what output it gives us out.